The universe is a very, very vast area that has existed for a very long time. It's difficult to imagine where it all has begun. There are stars, planets, comets, and asteroids are all present in our universe today. But they were not there all at its beginning. From where did they originate? We use the Big Bang Theory to explain how the universe came into being. It is the hypothesis that the universe started out as a single point, then grew and stretched to reach its current size, and it is still stretching. According to this theory, the Big Bang Theory, the universe was created more than 13 billion years ago from a single hot and dense point known as singularity. It didn't occur in an already existing place. Rather, it is initiated the expansion and the cooling of space itself. A minute, tiny beginning. There were only hot, tiny particles and light and energy at the beginning of this universe. Nothing compared to what we see today. It cooled down. It cooled down as everything grew and occupied more space. The minute particles gathered into a crowd. They developed atoms. The atoms are then put into groups. Atoms join together over a long period of time to create stars and galaxies. Larger atoms and group of atoms were produced by the first stars. More stars were born. As a result of that, galaxies were merging. So the two galaxies like Milky Way, Andromeda, the galaxies were merging and colliding at the same time as brand new stars formed and then died. Asteroids, comets, planets, and black holes emerged from there. So we have a question like why to support this theory? Why support this theory? It explains a lot of what astronomers, researchers, and people like us observe using telescopes on the ground and in space. It explains why. As space continues to expand, other galaxies are relocating away from us. It explains the glow that can be seen through the cosmos, throughout the cosmos. The glow is the warmth that the universe's creation left behind, which has since cooled down to just a few degrees above absolute zero. It's a remarkable effect and a beautiful concept of the origin of the observable universe, to put it briefly. According to this theory, hydrogen, helium, and lithium were first created, and from there, all heavier elements were produced in stars and supernova. Cosmic inflation, a continuation of the Big Bang, even explains why the universe is so homogeneous. Homogeneous means equally made up everywhere, and how galaxies are dispersed throughout the space. So let's see what is cosmic inflation. It's not the same sort of inflation. If space underwent an extraordinary expansion, explosion, not explosion, it's more like expansion very early in its history. A lot of characteristics of the universe as we know it today make sense. According to the inflation theory, the enormous amounts of energy present in space itself cause the universe to expand dramatically a very small fraction of a second right after the Big Bang. The universe continued to expand and cool after this time of inflation, but much more slowly. Space was rapidly expanded by the inflation, which resulted in a very uniform surface. But the universe is not uniformly uniform. During the inflation, minute variations in the matter density that existed in the early universe were greatly amplified. The universe's large scale structure, including the large sheets, bubbles, and galaxy clusters, was eventually produced by these density fluctuations.